What do we
Will you
have
be able to
here?
know that without graphing it?
Without graphing it, yeah. And the reason you would know is because you could use this right here. This is just a line. So a line, every point on the line is going to have a limit because it's going to approach the same y coordinate from both sides. Okay, so on number 2 now. It's continuous at 2. Well, obviously there's a hole there, so that's false. If it's not continuous, there's no way it can be differentiable. That's one of the 2 criteria to be differentiable. So 1, it has to be continuous. 2, it has to have the same slope on both sides as you get close to the point. So if it's not continuous, there's no way it's differentiable. So here the only one is the first one that's true.
Wait, what makes it not differentiable?
If it's not continuous, there's no way it can be differentiable.
Do you know why?
Well, that's just that's the 2 criteria for a function to be differentiable at a point. It has to be continuous and it has to have the same slope from both sides.
Okay.
But it can be, there is a way it could not be differentiable but still be continuous. Remember we had like a corner. So like right here at this point, it's continuous, but it's not differentiable. So don't assume that just because it's differentiable that it has to be not, or don't assume that if it's not differentiable that it's also not continuous. So I think I interrupted someone. Could you say your question again?
Can you do 13?
13, yeah, let's look at 13. So I'm gonna clear this out.
Once you get to 13, can you backtrack to 10?
Yeah. So I'll do 13 and I'll try to remember to do 10. Okay, so on 13, if you try u substitution here, you're gonna get stuck because if u was to equal x squared plus 1, your du would be 2x dx. Doesn't your x show up in the denominator? You never want du in the denominator. That's going to mess you up. So I'm just going to rewrite this integral here as, this is going to be the integral from 1 to e. This was like number 1. So you see how here we talked about you're going to see similar type questions. This is like number 1 from 2014. You have to split this up into 2 parts. So you can write this as x squared over x plus 1 over x dx. This is going to equal the integral of x, when you simplify x squared over x from 1 to e, plus 1 over x dx. And this is going to equal the integral of x, which is x squared over 2. And you guys should hopefully have memorized the integral of 1 over x. That's going to be natural log of x. I'll do absolute value of x from 1 to e. And then I'm going to come down here so I have more space. So when I plug in e here, this is going to give me e squared over 2 plus ln of absolute value of e minus, then I need a parenthesis since I'm going to distribute the minus. When I plug in 1, you get 1 squared over 2 plus ln of absolute value of 1. So this is going to equal e squared over 2. ln of e is just 1. So you're saying e raised to what number gives you e? Well, e to the 1 gives you e. Minus, and then in parentheses I have 1/2. ln of 1 is just 0 because e to the 0 gives you 1. So when you simplify this, this is e squared over 2 plus 1/2. Which if you want to write that as a single fraction, your answer would be e squared plus 1 over 2. So that's going to be letter B.
If you try to do that by integration by parts, would that even work? Or
integration by parts is when you have 2 factors. Like you're taking the integral of u dv, and you have to figure out which factor is your u and everything else is your dv. So you wouldn't do integration by parts here when it's a fraction.
oh, okay.
yeah, integration by parts is always based off of it's based off of 2 factors, but sometimes, like if you were to do integral of ln of x, one of your factors would just be dx. So you can do integration by parts for this one.
You can do it if it's a fraction.
Yeah, if it's a fraction, unless you can a fraction, you wouldn't do integration by parts.
All right, thank you.
Okay, so I'm going to do number 10, but any questions on 13 before I do 10? And before I clear out 13?
I have a question.
Yeah.
So, like, is knowing how to do these problems just kind of like that, knowing how to do like that problem specifically, just kind of learning from practice problems over time? Like, what the best technique is?
No, I've always been surprised how predictable the test is. They seem like they give the same types of questions year after year. I think they reward students who just practice through old AP tests. So yeah, just as you work through these, you see like what they're expecting of you. I almost see this as like a review that I'm giving you in class, where it's like, okay, these are the types of questions you're going to see on the test, because they like to reuse, even if it's not, some of them maybe don't come up every year, but there's a lot of them that might be every other year, every 3 years. That's why we're doing several different years, so you can hopefully get a good idea of what you're going to see on May 5th.
Okay, thank you.
Hopefully May 5th.
No, it should be May 5th, whether it's at home or at school or somewhere. I don't know how they would do it at home, but that's what they're talking about.
They're trying to move it online.
We should just do a Zoom session that day.
That would be fun. Maybe they'll have proctors watch you on Zoom. I have no idea. They're supposed to make an announcement tomorrow. So check the College Board Twitter or something. Okay, so I'm going to do number 10 now. Okay, so number 10, this is going to be implicit differentiation when you don't have y by itself. Most of the time we do explicit differentiation, where you already have y by itself and you're just differentiating for a single variable. But if you don't want to get y by itself, which you probably don't want to do on number 10 because it's messy, I'm going to do implicit differentiation. So right here, and we saw one of these on 2014 also, so this should not be a surprise. So we're going to do implicit differentiation on number 10. I'm hoping you're already starting to see similar problems as you work through the 2008 test, but you're going to see more and more as you go. Okay, so taking the derivative of this, I'm going to get 2x plus, for xy, I have to do the product rule. So it's going to be the first factor times the derivative of the second. So the derivative of y is just dy over dx. Plus the second factor times the derivative of the first. So the derivative of x is just 1. So you don't have to say times by 1. So think of it like this. So you don't have to write this down, but if you're taking the derivative of x, that would just be dx over dx. Anything divided by itself, change in x over change in x is just 1. If you're taking the derivative of y with respect to x, it's just going to be dy over dx. So the derivative of x is just 1. The derivative of y is dy over dx. Okay, so that's separate. Okay, so I just did product rule. Now I'm going to take the derivative of y squared. Think of this as chain rule. So you're doing the derivative of y squared, which is 2y, times the derivative of the inside function, which is y. So the derivative of y we showed on the left is dy over dx. For x squared, you could still do chain rule, but it's just 2x times dx over dx, which is just 2x. And the derivative of a constant, please remember, is always 0. Doesn't matter what the constant is. So any questions on the setup? The rest is just algebra. Okay. So for the rest of this problem, it says, what is the slope? So that's the same as saying find dy over dx. Fine, sorry, it's messy. dy over dx. Okay, so I'm going to be plugging in stuff. So this is my x, this is my y. So I'm going to write this as 2 times 2 plus x, which is 2, times dy over dx. And then y is just 1. And then this y is a 1. And we just have to get dy over dx by itself. Okay, so this becomes 4. So when you combine 4 and 1, that's going to give you 5. When you combine these two, so 2 times the variable plus 2 times the same variable is just 4 times the variable. So I'm just combining like terms. So you add the coefficients to get 4, and then you have dy over dx. So it's the same as doing 2a plus 2a equals 4a. So 2 dy over dx plus 2 dy over dx equals 4 dy over dx equals 0. And just solve this equation. What's going on with my pen here? So dy equals, subtract 5 to both sides and then divide by 4. So it's going to be letter B.
Could you do number 8?
Yeah, I'll do 8. Any questions on 10 before I start number 8? Okay, so I'm going to clear out number 10. Okay, so number 8, we are doing LRAM. I think 2014 had RRAM, so make sure you know these rectangular approximation methods. Okay, so on number 8, so it's very important to read the problem carefully. So this is LRAM here. So for LRAM, I'm not going to use the last point because that's using the far right side of the rectangle, which we're not using. So I'm going to create 4 rectangles. It's this picture, no, the picture is for number 9. Okay, so I'm just using the table. So I'm creating 4 rectangles. So to go from 2 to 3, doesn't that have an area, or that has a base of 1, right? To go to 2, from 2 to 3. And then I'm going to use this y coordinate here, which is 6. So that's going to be my first rectangle. The rectangle has a width of 1 and a height of 6. For the second rectangle, if you go from 3 to 5, what's the width of that rectangle?
2?
It's okay to turn your 2. Thank you. It's okay to turn your mic on once in a while. So 2. And then I'm going to use the next y coordinate, which is -2. And then from 5 to 8, that has a width of 3. And then I'm going to use the next y coordinate, which is -1. And if you go from 8 to 13, that rectangle has a width of 5. And then the next y coordinate is 3. So this is going to equal 6 minus 4 minus 3 plus 15. Doing some mental math. 2 minus 3 is -1 plus 15 is 14. So even if you missed this one on 2014 and 2008, this is the kind of question I expect you to get right on the AP test because it shows up all the time. Just using basic LRAM or RRAM, using it from a table. So don't beat yourself up if you're not getting it. That's why we're spending all this time reviewing, to get you to the place where you need to be.
Mr. Morrison,
Yeah.
if it's RM, do you like exclude 6?
So yeah, if it was RRAM, then I would exclude that, and then I would be using all of the rest of them.
Okay, thank you.
Uh-huh.
Mr. Morrison,
Mr. Morrison.
could you do number 9?
Oh, I have a question on this one.
Okay, so I'll take questions on 8 and then I'll do number 9. So if I didn't get to you, just I'm going to make sure to answer everyone's question before I go to the next page. So I'll do number 9, but what was the question on number 8?
So how come you wouldn't use both of the y values? For example, from 2 to 3, like 6 and -2? Because I get like how that's the trap one, but I'm kind of confused.
Why you wouldn't use 6 and -2? I'm not sure I understand your question, because I did use the 6 and the -2 here and here.
Oh, I mean like using the base for 1, and then you do 6, and then plus -2 over 2.
Plus -2 over 2. You might be thinking trapezoid rule when you factor out a 1/2.
Mm-hmm.
So that if it says to use trapezoids, then you can factor out a 1/2 because that's part of the trapezoid formula.
Okay. So
Yeah.
okay, cool.
Yeah, trapezoids would use the 1/2 that you pull out.
Okay.
Mr. Morrison,
Yeah.
for this one, for MRAM, you just take the averages, right?
For MRAM, yeah, you take the average. So you do like, I don't think you could, let me see. You wouldn't be able to do MRAM for this problem because you would need a function, but you would average like 2 and 3 to get 2.5, and then 3 and 5 to get 4, 5 and 8 to get 6.5, and then average 8 and 13 to get 10.5. I'm seeing a lot of people with their videos turned off, so make sure, and I see people like getting distracted, so make sure you guys are staying with us. So please make sure your videos are turned on. Just want to make sure that you're taking advantage of this time. So I am kind of randomly scrolling through to see who's with us.
I don't got a webcam, so.
Okay, but just if you're able to, make sure that you can join us, please. So video should stay turned on, but mic's off unless you have a question. We even have Meyer here.
I'm Meyer.
Okay, so number 9, I think, was the next one, right? Can someone confirm you asked number 9?
Yeah, number 9.
Yeah.
Okay, so number 9. So we're using the figure above. So the is shown in the, if g of x equals the integral from -2 to x, which of the following values is the greatest? Okay, so let's see here. We're starting at -2. If you go from -2 to -3, so for this one, won't this, because you're going from right to left, because -2 is on the bottom. If you go from -2 to -3, isn't that, whenever you go right to left, don't you take the opposite of the area? So this is -2. If you're starting at -2 and then going to -3, that would be, this will be a negative number right here. If you're finding g of -2, what's the integral from -2 to -2?
0.
That's going to be 0. If you go from -2 to 0, let me erase this. So -2 to 0, that's going to be positive area right there. So it could be that one. If you go -2 to 1, so it's not going to be A or B because we just got one that has positive area. So if I go from -2 to 1, isn't this even more positive area going from -2 to 1? So it's not going to be C. So if I'm going from -2 to 1, that's going to give me even more positive area. If I go from -2 to 2, see how this includes some negative area in it? So it's not going to be this one because you're subtracting, you're taking away from the area from -2 to 1. So my answer here would be D. So you're trying to find the one with the most positive area. So that's going from -2 to 1, the area that I highlighted.
All right, thank you.
Can you do number 18?
Yeah, I was gonna see if there's anything else first on, I think this page is through 14 on the first page.
11.
Yeah.
Okay, so I'll do 11. Okay, so number 11. So I'm going to integrate here. If it says greater than or equal to 3, that means it's the same as saying from 3 to infinity. So I'm going to take the integral from 3 to infinity of e to the -2x dx. If you want to find the area between the graph and the x-axis, that's what we do when we take the integral. You're finding the area between the graph and the x-axis. Okay, so for this one, you don't have to do u substitution. I gave you a formula for this, but if you wanted to do u substitution, you could if you forgot the formula. So it's u equals -2x, du equals -2 dx, and then 1/2 or -1/2 du is going to equal dx. So I can rewrite this integral as, and I'm also going to change the limits of integration. So this one's interesting because if you do -2 times x as x goes to infinity, this will become -infinity. When you plug in 3 for x, -2 times 3 is -6. And then I have e to the u. And then my dx is going to turn into -1/2 du. So this is going to equal -1/2 times e to the u, which is the integral of e to the u, from -6 to infinity, to -infinity. So this is going to equal -1/2 times e to the -infinity minus e to the -6. Well, e to the -infinity, that's 1 over e to the infinity. That just goes to 0. Minus 1 over e to the 6. So negative times a negative is a positive. So this should give me 1 over 2 e to the 6. Which for number 11 is letter A.
It's E.
What's that?
I looked at the wrong one.
Mr. Morrison, why did do you have to do u sub? Can't you just use like the?
No, I could give you a rule. It's just e to the -2x over -2. That's the rule. And then if you want to just keep it in terms of x, that would also give you the answer.
Mr. Marson, why is your bounds to infinity?
Why are my bounds infinity?
Like you're from 3 to infinity.
It says all x greater than 3, so everything greater than 3 is
this right here is the same as saying this. So from 3 to infinity.
Okay, thank you.
Mm-hmm.
Mr. Morrison, can we explain like for 12, like do we just like have to guess for each option, or like is there like an easier way to like tell for that one?
Well, sometimes you can look at it quickly and you know that it doesn't converge. So we can talk about 12. So let's see 12. I'm going to clear out 11 if there's no questions on 11. Okay. So on number 12, so which of the following series converges for all x? So if it converges, you know just from looking at it that A doesn't converge because the denominator or the numerator is getting bigger faster than the denominator. Then on number 12, same thing on B. So you can tell just from looking at it that this one diverges whenever the numerator gets bigger faster than the denominator. Same thing on C. So we've already ruled out 3 of them just from looking at it. You know, they all diverge when the numerator is growing faster than the denominator. So D, I can't tell from looking at it. So I'm going to do, when I see a factorial, I'm going to do a ratio test. Even if you did have to test all of them, it might be worth your time if you know what you're doing. If you see a problem where you're like, okay, I just need to spend a little more time, but know that you're getting it correct, I think that's okay. And spend less time on the really difficult ones, but more time on the ones you're familiar with what they're asking. Okay, so on D, I'm going to do ratio test here. So ratio test. So it's going to be limit as n approaches infinity. So every n is going to change to an n plus 1. And then I'm going to times by the reciprocal of what we started with. Reed loves the ratio test, and Julia.
I do love the ratio test, Mr. Morrison.
The ratio test is pretty amazing. Okay, so right here, I'm going to write this as e to the n times e, and then x to the n times x. And then I'm going to expand the bigger factorial. So the bigger factorial is n plus 1. So I'm going to write n plus 1 factorial as n plus 1 times n factorial when you subtract 1 from n plus 1. Then you have e to the n x to the n. And to use the ratio test, this limit needs to be less than 1 if you want to see that it converges. So right now, I'm going to do e to the n is going to cancel out, n factorials cancel out, x to the n's cancel out. So what you have left is the limit as n approaches infinity. So you have on top, you have an e and an x over n plus 1. Well, no matter what x is, as if the denominator is growing without bound, this will always equal 0, which will always be less than 1. So my answer is D. I don't even have to check D if I know that D converges. Yeah.
Couldn't you just say that, like, if you get one of these on the test, couldn't you just assume that whichever one has a factorial in the denominator is always going to converge for all real numbers?
Yeah, because if you expand, because that's going to keep your n in the denominator. Well, yeah, that's probably okay. I'm afraid to say always in case there's a twist to how the problem was written or somehow something canceled out, but it's a pretty safe bet. I think that would work. Because that's going to cause the n to stay in the denominator, which will cause the limit to equal 0. So I'm guessing what you said is correct, but in case there is some twist to the problem, I'd just be afraid to say it works for every problem.
Mr. Morrison, why did you eliminate A, B, and C?
Just because for all 3 of them, the numerator grows faster than the denominator. So you know just from looking at it that it diverges.
If the denominator grows faster, then that just means it converges?
If the denominator grows faster, then it could converge. But we don't know that for sure without one of the tests.
E, the numerator is growing faster, could you just be like, assume that it's D then?
Yeah, I guess if you looked at E and eliminated that one, that would work. But it's important to know, why D converges, because it could be a free response question. Okay, so other questions on the first page. Okay, we're gonna move on. to the second page here. Okay, I'm going to take questions on 14 through 24.
Can you do 18?
18, yeah. Look at number 18. Okay, so on 18, it says the word tangent line, so that tells me that I need to find the slope. So I see this word here. So for 18, I'm going to find m, which is the same as y prime. So that's going to be, when you take the derivative of this equation here, it's just going to be 2x plus 3. And then for the second equation, often with these, you want to find two different derivatives and set them equal to each other. So you've seen that we were doing that on other tests. So again, these are things you should recognize when you get to the AP test. So like right here, this is y equals negative x plus k when you get y by itself. So for this one, doesn't m, the slope, just equal -1 from right here? The number, the coefficient of x. So now I can say that I was able to write the slope two different ways. So then I would just set those slopes equal to each other. So I would say -1 can be the slope. And then 2x plus 3 also would be the slope. Where'd my k go? Let's see, 2x plus 3, I'll get there. So 2x plus 3, let's first solve for x. Oh, I think I see it. Okay, I think I'm good. So 2x plus 3 is going to equal -1. So when I solve for x, so I'm finding the x coordinate where this is true. So I'm going to subtract 3 to both sides, and then x equals -2. Okay, so now that I know what x is, let's see, I can plug that back into, because I want to solve for k. So I have x plus y equals k. So I can say that -2 plus y equals k. Well, if you want to solve for y, don't you just plug -2 into this one? And then solve for y that way? So when I solve for y is going to equal, so you square -2, you get 4. You do 3 times -2 to get -6 plus 1. So y is going to be -1. So I'll put that here. So -2, you add that to -1, and that's your answer. So k equals -3.
All right, thank you.
Can you do 16?
There were 22. Oh.
Or someone was, I think, was talking before that. Can I do which one?
Just leave it up there for a bit.
16. Okay, I'll do 16, and then I'll try to remember to do 22, but remind me if I forget. So I'm going to do 22. Leave this up a few more seconds.
You're good.
Okay. So 22, then 16. Oops. So we're using the table above. Okay, so on 22, looks like I have to do integration by parts here when I'm taking the integral of a product. Again, I wouldn't expect you to know that when you're doing the 2014 test, like number 92. But as we do more of these, you'll start to see similar problems. Okay, so using integration by parts, I'm going to set u, oops. Say u equals, so for 22, I'm going to set u equal to f of x. Hopefully this one's not as bad as 92. That one was a beast. So dv equals, It's going to be whatever's left over, which is g prime of x dx. And the reason I would use g prime is because if v is g prime, or u is g prime, du would be g double prime, which doesn't show up in the table. So have a plan going into this. Make sure you don't get something that doesn't show up on the table. Okay, so du is going to be f prime of x dx. And then v, when you take the integral of g prime, it's just g of x. So using ultraviolet voodoo for this one, this is going to be uv. So I don't think this one is as bad as the one from 2014
Oh, this
test.
one's
So
like 92, right? Okay.
yeah, but I don't think you have to do integration by parts here twice here.
I think I
Or
get it.
I don't think there's any tricks to this one either. So uv minus the integral of v du. So g of x or du. Okay, let's see what we get. So v du, f prime of x. Okay, so this is good news. Isn't that what we started with?
Yes.
Okay, so right here, this is the same thing we started with. So this is, I can say this equals the integral. So I'm going from 0 to 1. So it's g of x. I'm just copying down the original problem, just switching the order. Okay, so then f of x, g prime of x equals
Morrison.
what? Yeah.
How come you can't just set it equal to 5 since that also equals 5?
I could, but then I don't know how that's going to solve for what it's asking me to solve for.
Oh, I guess you're right. Okay.
So let's see.
Mr. Morrison, it
Yeah.
looks like the new integral formula we have isn't the one that we started off with. It's actually the one that equals 5. So they gave us the f prime of x g times g of x d integral equals 5, but the one we started with was the f of x g prime of x.
Okay, so let me erase this part. So I'm just going to write it like this, since we know that this integral should just equal 5. So this is going to equal, since we're doing this whole thing from 0 to 1, I can write this as f of 1, g of 1, minus, and then I plug in 0, I have f of 0, g of 0. And I am going to be using what we started with here, but now I'm just going to change it to 5. That's why it gave me that. So this should work now. So when I find f of 1 from the table, f of 1 is just 4. And then from the table, what's g of 1? G of 1 is 3. And then f of 0 is 2. G of 0 is -4. And then I was able to substitute the original problem in to get -5. And this is going to be 12 plus 8 minus 5, which equals 15. Okay, so that one almost messed me up again. These are the ones that I should have practiced ahead of time to really think on these. Get some white. Okay, so is that okay for 22?
For when you integrate it by parts,
Mhm.
how come f of x gx is in those brackets with the 0 to 1? Kind of confused in that.
Oh, that just means I'm plugging in the 1. Let me use a different color. So I put it in the 0 to 1 because that tells me first I'm plugging in 1 to that, and then I'm subtracting whatever I get when I plug in 0 into that.
But
So you always plug in the top number and then plug in the bottom number and then subtract those two things.
Doesn't it have to be an integral to do that though?
No, this isn't an integral here. Well, this is based off of ultraviolet voodoo, which is, it comes from right here. You're taking the integral of this whole thing. So the whole thing you're doing 0 to 1.
Oh, okay.
Okay. Or someone asked another one. So if you asked a question a few minutes ago, can you remind me what it was?
It was 16.
16, thank you. That's right. Okay, so I'm going to clear out number 22. Let's do number 16. Yeah, I know we're running low on time, but I'm just going to keep going. So on 16, I know we still have 15 more minutes until noon. So, all right, so 16. For what values of x does the series converge? So this one is geometric. So on 16, you can probably see that there's a lot of series on here because that's one of the big topics for BC. Okay, so on 16, I'm going to take my base and say that this has to be between -1 and 1. So doing a little fancy algebra here. So on 16, I'm going to times all three parts by x squared plus 1. So I distribute the -1. When I times the middle by x squared plus 1, it's just 2. When I times the right by x squared plus 1, it's just x squared plus 1. So now I'm going to split this up into two integrals. So here I would say that 2, or negative x squared minus 1 is less than 2, and 2 is less than x squared plus 1. So for this first one, I'm going to come down here so where I have a little bit more space. So it's going to be, I'm going to add 1 to both sides. And then when you times both sides by a negative, it becomes greater than. You flip the inequality sign. Well, x squared is greater than -3. Isn't that true for all real numbers? So true. This is the symbol for all real numbers. So no matter what you plug in for x, if you square it, it's always bigger than -3. So that's not going to help me any. So let me go to the other one. So over here, it's x squared is greater than, I subtract 1 to both sides, I get 1. To say x squared is greater than 1, that's the same as saying the absolute value of x, when you take the square root of 1, has to be greater than 1. So this tells me that x is greater than 1, or x can be less than -1. So my answer would be D. So in order for, I would focus on this one. So in order for x squared to be bigger than 1, that means that x could either be larger than 1 or it could be smaller than -1. That would make that inequality true. So you have to interpret that inequality. You can also do it using a table. So like -1 to 1. So any number you pick smaller than -1 would make it true. Any number in between would make it false. That this is true. Any number you pick bigger than 1 would make it true.
Morrison,
Yeah.
can you just do it like absolute value of r has to be less than 1, and then so r equals 2 over x squared plus 1, and then find which options make r less than 1. So you plug in like the different values for x, and I got the right answer doing that.
Yeah, no, that's fine. You could just, I just introduced absolute value later in the problem, but you could do it that way too.
Can you do number 19?
Yes. So number 19. So I'm gonna clear this one out, and then I'm gonna do 19.
17 as well.
Okay, so I'll do 19 and 17. Okay, so number 19. What do we have here? So for this one, I'm gonna do partial fractions. So I'm gonna do a little scratch work here. So 7x over 2x minus 3 times x plus 2. This is gonna equal a over 2x minus 3 plus b over x plus 2. Okay, so if I want to solve for a, what number will make the denominator under a 0? If you set 2x minus 3 equals 0, what do you get?
3 halves.
3 halves. So what I would do now is I would cross this off, and I would plug in 3 halves in for this. So when you do that, you get 7 times 3 halves over 3 halves plus 2. And that's going to equal 3. So I said 7 times 3 halves over 3 halves plus 2. Okay, now, what number will make under b? Wouldn't -2 make that 0? So when you plug in -2 here, you would cross off. I still have my eraser. Okay, so when I'm plugging in -2, I would cross this off and plug in -2 there. So you get 7 times -2 is -14. On the bottom, you have -7. So -14 divided by -7 is 2. This is 18. Okay, so that means I can rewrite this, coming back to this integral. I just solved for a and b. I can rewrite this as the integral of, instead of a, I'm going to say 3 over 2x minus 3. Plus, instead of b, I'm going to say 2 over x plus 2. So this is going to equal, for the first part, it's going to be 3 times ln of absolute value of 2x minus 3. But you'd have to do u substitution here. So if u equal 2x minus 3, your du is going to be 2 dx. And then when you solve for dx, you're going to get 1/2 du equals dx. So that means I need to, at some point, I have to times this integral by a 1/2. Plus, let me just separate this off. So plus, and then for the second part, it's going to be 2 times ln of absolute value of x minus 2. And then I just need to put my plus C. And then from here, hopefully you can see that the answer for 19 is going to be A. So the 3 and the 1/2 becomes a 3/2.
Can you explain the one, like the 1/2 part?
Yeah, so I just, from this step here, I just times both sides by 1/2. So that's going to create a 1/2 in front of my integral when I pull that out. So I have to times the whole thing by 1/2.
Why are you doing u sub place?
Because see how there's an inside function of 2x minus 3? So that, it's kind of like you're undoing chain rule. Whenever you undo chain rule, you want to do u substitution.
Okay. Okay.
Because of that 2 in front of the x. It's like if you were to take the derivative, you have to do chain rule. So if you take the integral, you have to do u substitution.
Okay, I see. Thank you.
Mm-hmm.
Thank you.
Uh-huh.
Mr. Morris.
Yeah.
Could you have gotten 3/2 by just like looking at it and just saying like like x is 3/2 because 2x minus 3 as well?
Yeah, 2x minus 3, you just take the derivative of that, which is 2, and then the reciprocal, that would be fine.
Okay, thank you.
Mm-hmm. Okay, other questions here on this page?
17, please.
17, okay, I'm gonna clear this out. I'm gonna do 17. Okay, so on 17, so this is a good one that it kind of looks hard, but it's not, and you're gonna see problems like this on the AP test where they give you a function and you have to take the derivative of the function that's in function notation. So this one, I'm gonna take the derivative of both sides, so I have to do chain rule. So remember chain rule, you take the derivative of the outside function, keeping the inside the same, and then you times by the derivative of the inside function. So the derivative of x squared minus 3 is going to be 2x. So if I want to find, it's telling me to find f prime of 2. So I'm going to find f prime of 2 equals h prime of 2 squared minus 3. Then I have 2 times 2 here. So this is going to equal h prime of 4 minus 3, which is 1. Then I'm going to multiply that by 4. And that would be, that's equivalent to letter B. Sometimes they give you a table, but this one, it just leaves the answer in terms of the function h.
Thank you.
Other, could probably do one more before, I'm going to keep going, but one more and then I'll kind of just wrap it up for anyone that needs to leave.
20. 20.
Number 20.
I think I heard 20, right?
Yes, 20.
Okay, so I'll do 20. All right, so number 20. What is the sum of the series? Okay, so for this one here, I'm going to manipulate the series e to the x because it's not alternating. It's kind of like e to the x. It sort of looks like the Maclaurin series e to the x where x would just be ln of 2. So here I'm going to say e to the x equals, so the formula that you should have memorized is 1 plus x squared over 2 factorial plus dot 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 x to the n over n factorial. So if I was to change this x to an ln of 2, oops. That's going to mean I'm going to write it as 1 plus ln of 2 plus ln of 2 squared over 2 factorial plus dot 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 ln of 2 to the n over n factorial. So right here, isn't that what we started with up here? Didn't I just generate this series as e to the ln of 2? Can someone tell me what e to the ln of 2 equals without using your calculator?
2.
It's just 2. So for number 20, my answer is 2. E to the ln of anything is just the anything. So any questions on number 20?
Wait, why is it 2? Sorry.
E to the ln of 2 just equals 2. Like e to the ln of a million equals a million. So just know that e to the ln of a number just equals the number.
You don't have to worry about anything else. That's it.
What's that?
You don't have to worry about anything else. That's it.
That's all.
All right.
You just have to recognize that it's in the form e to the x where you're plugging in ln of 2 for x. So again, that probably would be something you might not recognize the first time around, but as you see problems that are similar to it, it should you'll know what to do on the AP test. Okay, just for the people that need to leave, I'm just going to wrap it up. Like I said, I'm going to keep going. So definitely encourage everyone to stick around if you're able. But since the next time we meet is going to be after break, I posted on School Loops on the extra credit possibility you can start working on. I'm going to make it due April 6th. So we're still planning on being back April 6th. I know that can change, and there's a good chance it will. So we'll make adjustments as needed. But either way, I'm going to make it due April 6th. So just plan on, if you're able to do that, you can work on it over spring break or after. But if you're able to start before or during spring break, that would be best. Also, the next assignment that's going to be due Monday. The next time I see you, I don't know what day that is. Let's see, what's today, the 19th? So it'd be the 23rd, the 30th, I believe. So that'll be the 2003 test. So I'll probably send out one more email, maybe later today, just so you know what to expect the week after break. So hopefully Monday, Wednesday, Friday will work for you guys, same time. So we're gonna be moving a little faster after spring break because that's kind of crunch time for getting ready for the AP test. And then I think that's pretty much it. Like I said, I'll send one more email, hopefully not more than one. Since I know you missed the days when your phones were totally dry, but now all these teachers are bugging you and you get all these notifications.
Daniel, bro, he's talking about you.
Hey, yo, can you like start later?
That
it's simple. It's early. Can you start at 12 or something? Some more saying.
Are you talking to me?
Yeah.
Yeah, I'll do number 12. I just want to make sure everyone's.
Can you start like at 12? Like early, like later?
Oh, no, you need to get up. Also, you should do workouts in the morning. Like find workout videos. You don't have to go outside and expose yourself to any viruses. Right. Stay active. It keeps your brain working the way it's supposed to.
Alligator.
Okay, so I'm gonna. Yeah.
Will you like post a recording of this on Google Classroom?
Yeah, I'll try to send out a recording. I didn't do 2014, but I should have most of 2008 that I can send you.
Okay. All right. Thank you.
All right. So if you are leaving, have a great spring break, and we'll get back together on the Monday after spring break for another Zoom session. So just check your Google Classroom. I'll try to give you something, like I said, today, so you can prepare for that if you need to make any plans. Okay, so I'm just going to keep going here for anyone that can stay. So other questions?
Can you do 24?
I think I heard 22 first and then 24. Someone say 22?
I did, yeah.
Okay, so let's do 22. All right, so let's look 22 here.
We already did 22.
Did we do 22?
Yeah, we did 22 already.
Oh, we did again.
Sorry. Okay, so 24. This actually describes how the virus is moving, and we're trying to flatten the curve, if you've heard that expression. So growing logistically. Just a side note here, since we're talking about logistic growth, when it says flatten the curve, they're hoping, they being the government or whoever's making the decisions, they want it to start going like this, so it comes back down. They want to avoid getting to this point where it spirals out of control, where the rate of change is the greatest until it affects the majority of the population, or as it approaches the asymptote. So that's logistic growth and how it's trying to prevent, because they don't want it to go to this point where eventually it'll still come down, but it's going to affect a lot more people if it follows the logistic growth model. Okay, so anyways, So number 24. So I'm going to rate that dp over dt equals, so the formula I'm going to use is kp times 1 minus p over m. So this is one way you can write a logistic growth model. So this is going to equal, if you look down here at the choices, or what are we working with? My m is 200. Okay, so this is going to give me, if I was to do, looking at all the choices here, just make sure I have the right form. Okay, so this is going to be 0.2 p times 1 minus 0.005 p. Just a little side note, you could do 0.001 divided by 2. That's going to equal 0.005. So basing it off of the fact that m is 200, I can get this here, and then I can rate this as 0.2 times p. So 0.005 is the same as 5 over 1,000 because it's to the thousands place. So I'm going to write this as 5p over 1,000. So this one here is going to be 0.2 p. When you simplify this, you get 1 minus p over 200, which gives me my maximum. So for this one here, this is going to be letter A.
Mr. Morrison?
Yes.
Where are you getting the 0.2?
From right here. I was trying A.
Oh, I see.
So I was seeing if you could write A. I was seeing if you could
trial
write
and
A
error.
in this form. So I'm just kind of looking at them and seeing which one can I put into this form where it gives me a maximum of 200, which is what I have here. So yeah, it's kind of trial and error. You're just looking at which ones and you say which of these equations could represent this graph here.
Right, so what gets plugged into where? So kind of confused. Like that 0.001, what do you do?
Yeah, for this one, if you factor out a 0.02p, it gives you, so I just factored out the 0.02p. So where I got the 0.005 from is right here. Because I was just simplifying it so that when I distribute it, I get back to where I started.
You did. So 0.001 was your P?
0.001 wouldn't be the P, but that would just be based off of this coefficient. When you do it, divide it by 2, that would give you this number right here, 0.005. So that you distribute the 0.02p to get back to where you started. I'm trying to write this letter A in this form right here. I'm seeing if I can write it in that form where m is 200.
Okay.
We'll do more of these. That was a hard logistic one. They're usually not this difficult.
Okay.
What's the difference between this version and the KP times m minus?
I just use this one for the AP test. It's always going to use this one here.
Okay.
Okay, other questions? I think I heard another question before someone said 24. Anyone?
I had said 22, but we already did it. That's probably
okay. That's what it was. Thank you. Okay, other questions on this page?
Can you do 25?
25. Let's look at 25. So I'm going to delete this. And again, 24 was a difficult logistic one. They're usually going to be easier than this one. This one you just kind of had to go choice by choice to see which one fit the logistic growth model. Okay, so 25. Oh, I think that's the next page. Anything else on this page before I do? I can start with 25 though when I get to the next page. Anything else on this one? Okay, so I'm going to move to 25 then. Okay, so on 25, it's like a snowman. Are we using the, no, we're not using the graph. So, okay, so 25 here. It says, what is the value of C plus D? So for this one, if it's asking, if it says F is differentiable, that means I can take the derivative. So I can say F prime of X. I take the derivative of the top piece and the bottom piece. So when I take the derivative of the top piece, it's just C. And then for the bottom piece, it's going to be 2x minus C. So in order to be differentiable, it has to have the same derivative. So I guess I could just say, you don't have to write this, but I'll add this just so it's showing where it equals that derivative. Okay, so definition of differentiable, it has to be continuous and it has to have the same slope from both sides. For this problem, it's the same slope on both sides of 2. So that means that this value would have to equal this one. So I'm going to say C equals 2x minus C. The only place we're worried about it not being differentiable is at 2. That's the cutoff where it switches from one to the other. It's going to be continuous and differentiable for each piece separately, but I just want to make sure that it's also differentiable at 2. So I'm going to let x be 2. And I'm going to plug that in here. So C is going to equal 2 times 2 minus C. So when I add C to both sides, I get 2C equals 4. So C equals 2. Okay, now it also has to be continuous. So to be continuous, that means the original expressions have to be equal. So I'm gonna say these two things, this is what's gonna make it continuous. So let me actually, or maybe I should have started with this one. I guess it doesn't matter which one you start with, but for the here, I'll say Cx plus D has to equal x squared minus Cx. And again, the point that I'm concerned about is where x equals 2. If I can show that it's differentiable at x equals 2, it's gonna be differentiable everywhere. So I'm gonna change this to x to a 2. So this is gonna be 2c plus d equals 2 squared becomes 4 minus 2c. And we know that c equals 2 from over here. So I'm going to say 2 times 2 plus d equals 4 minus 2 times 2. So this is going to be 4 plus d equals 4 minus 4 is just 0. So d equals negative 4. So the question is asking me, it's kind of an interesting question, find c plus d. So we know c is 2. We know d is negative 4. So when you add those together, you get negative 2. So I'm guessing, I can't see the negative, but I'm guessing it has to be b, since d is positive 2.
Mr. Morrison?
Yep.
How come you did that whole derivative step in the beginning?
Oh, I guess I did need to do the derivative first because I need to know what c was before I could solve for d. So I was showing here, I'm showing the derivatives have to be equal to show that it could be differentiable, but then I also need to show that it's continuous. So there's, anytime a function is differentiable at a point, it has to meet 2 conditions. So number 1, it has to be continuous. And number 2, it has to have the same derivative from both sides of the x value. So in this case, it has to be the same slope from both sides of 2. It has to approach the same slope.
So that's checking if it's differentiable or continuous?
So this part over here is differentiable.
Okay.
But before you can say that it's differentiable, so that means the limit of f of x as you approach, or f prime of x as you approach 2 from the left has to equal the slope as you approach 2 from the right. So this part has to do, this shows that it's differentiable, but you also need to know that it's continuous before you can say that it's differentiable. So over here, you're showing that it's continuous.
So how come you did the differentiable one first?
Just because I needed to know what C was in order to solve for D. See how I plugged in 2 to
Yeah.
solve for D? So I would have got, if I started with continuous, I would have gotten stuck on the second step because I wouldn't be able to solve for D.
Okay, then I'm kind of confused when you're saying that you can't see if it's differentiable if it's not continuous. So how are you able to
Well,
do
it has
that?
to be both. So it doesn't matter which one you do first. Just both of these have to be true.
I got it. Okay.
Mr. Morrison,
Yeah.
can you do 28?
Yeah, let's look at 28.
Can you do 26 after?
Okay, probably remind me. I'll try to remember, but I'm going to do 28 now. So I'm clearing this out. Okay, so on 28, okay, so right here, we have dx over dt. Let me do a snap. Sorry, I'm eating and doing math at the same time. Okay. So are we okay so far? I just took dy over dt, which is what it's telling me to find right here. So I'm taking the derivative of my y function, and I'm timesing by dx over dt. So I need to know what dx over dt equals. So to find dx over dt, it's telling me a constant speed. That has to do with velocity. So my velocity formula is going to equal the square root of dx over dt squared plus dy over dt squared. So it tells me the velocity is 2 radical 10. So I have to solve, the goal is to solve for dx over dt, so I can plug it in here and figure out what dy over dt equals. Okay, so this is going to be the square root So dx over dt squared. And do we know what dy over dt is? Well, we can say it's this
Will it
whole
just
thing
be
here.
3 dx over dt?
Yeah, it'll be 3 dx over dt, good. So we solved for this earlier. I don't know what's going on with this. Sometimes it gets weird on me. So dx over dt. So I can say that 2 times the square root of 10 equals, I'm going to combine like terms. So this is going to be 4 times dx over dt squared.
Why wouldn't you square the 3?
Oh, you should. Thank you.
Oh, okay.
Okay, so right here, I'm going to make this 3 a 9 because it also needs to be squared. Okay, so let me write this again. Okay, so this will be 3. That was also included as part of dy over dt. So 3 squared becomes a 9. When you add 9 to 1, that's going to make this a 10. So when you come, I'm doing 2 steps on one here. Squaring the 3 and the dx over dt. So you have 1 dx over dt squared plus 9 dx over dt squared, which becomes 10 dx over dt squared. So I am going to write this as 2 radical 10 equals, you can pull out a dx over dt since you're taking the square root of dx over dt squared. Square root of 10. When you divide both sides by square root of 10, they just both go away. So that means dx over dt equals 2. And then you could take 2, should be an equal sign, plug it in here, and then your answer is going to just be 3 times 2. Remember, you're solving for dy over dt. So when you do 3 times 2, that's just going to give you 6. That was a long one. Good thing Abraham's not here to comment. Okay. I know he would have said something. That's okay for 28?
Yeah.
There's only 20 of you left. I just want you guys to know that you're awesome. You'd still be awesome if you weren't here. But just know you guys have a special place in my heart now.
Thank you.
Mm-hmm.
This problem was a lot harder than I thought it was.
Me too. I didn't think it would be this hard. This might be a good one to skip.
Yeah.
So that's again part of the strategy. Part of why we're doing this isn't just to review calculus, it's also to learn test taking strategies. You should be able to take the AP test and quickly identify which are the familiar problems and which ones aren't. And then if it's not familiar, you don't know where to start, just move on to the next one. Nothing to feel bad about. You just want to be, you're on a treasure hunt. You're looking for problems you know how to do. It's nice knowing that you can know how to do 10 problems and you're still on pace to get a passing score. If you know 10 out of 45 for sure. Isn't that crazy? Just know how to do 10 problems out of 45 if you can know those for sure. But hopefully your goal is to get higher than a 3. That's just to get a 3. Okay, so other questions on this page. Oh wait, you said 26, right? Did someone say 26? Or was I dreaming?
Can you do 26?
Yeah, I'll do 26. I'm gonna clear this. Okay, I guess the total, okay, so this one I am using the figure. So which one gives the total area enclosed here? Okay, so for this one, if I'm going to focus right here, this is 0, and then it's going to go, you have a bunch of sectors that they're so tiny, they look like a radius. So we're starting with this one right here, which is theta equals 0. Okay, then I'm going from here to here. So this would be where theta equals pi. So the formula that I'm going to be using is 1/2 times the integral from, I can say alpha to beta, so you know they're angle measures when you see Greek letters. So alpha to beta, it's going to be r squared d theta. So this is going to equal 1/2 times, we just went from 0 to pi, and then our r is sine squared theta. So it's going to be sine squared theta, and you have to square this, d theta. So this is going to equal 1/2 times the integral from 0 to pi of sine to the 4th theta, d theta. And didn't we just find half the area? Don't we also need to find this area down here? So what would I do to this?
Multiply it times 2.
Multiply it by 2 using symmetry. We're going to double this. So my answer, 2 times 1/2 is just 1. So it's the integral from 0 to pi of sine to the 4th of theta, d theta, which is letter D.
Mr. Morrison,
Yeah.
you go over when you have to subtract like little r over big R, or like big R minus little r.
That's if you have like 2 separate graphs, like if you have something like a petal and a circle. So if you want to find this area, let me use a different color. So if you wanted to find this area right here, you would do the big radius squared minus the little radius squared. So the big radius would go with the petal, the little radius would go with the circle. So to get to the end of the petal, you have to move further away from the origin, from the pole. So this would be a problem where you would do whatever the petal formula is, squared, that radius, and then you subtract the radius of the circle squared. So that'll leave you with, you subtract the radius of the circle because that would get rid of this area in here. So that's what you'd be subtracting to get rid of that area.
Okay.
And you would use the intersection points here. So from here to here. Okay, other questions?
Can you explain 76?
76, yes. Let's look at 76. 76 here. Are we using the, yeah, we're using the picture again. So on 76, So this is which of the following statements is true? Okay, so on 76, AF has a local minimum at x equals c. Well, it's changing from, the derivative is changing from positive to negative, so that would be a maximum. So it's not going to be A. It's from above the x-axis to below. Notice this is the derivative graph. They're asking you about the original function f. So when the derivative changes from positive to negative, you have a maximum. B, it says you have a minimum at B. Well, this has to do with concavity when the derivative is 0, so it's not going to be B. They're trying to trick you there, because this is when the derivative of the derivative is 0 right here. So that would be an inflection point. Letter C, the graph has an inflection point at A, f of A. So this would be from minus to plus, this would be a min. So it's not an inflection point, so it's not C. The graph has an inflection point at B, f of B. That would be true. So D is my answer, because right here at B, isn't the derivative changing from positive to negative? The derivative is increasing, then the derivative is decreasing. So whenever that happens, when the sign changes of the derivative, of the second derivative, so let me highlight this. So it's increasing, increasing, increasing. So if the derivative is increasing, that means the second derivative is positive. If the derivative is decreasing, the second derivative is negative. So D would be true. So is that okay for 76?
Yeah.
Okay. Other questions on this page? Okay, we can switch to the last page then, I believe. So I'm going to clear this out. Everyone's okay? Okay, so this is the last page here, 81 through 92. Oh, this one's kind of cool. Yeah, go ahead, I'm sorry.
Can you do 87?
87, yeah. So I like this one because it tells you what % of students got the problem correct. You can see there's problems on here. Like, I totally blanked. What problem did you ask? I'm sorry.
87.
87, thank you. Okay, so 87, but just before I start 87, I just want to talk about the answers. So you can see there's problems on here, like number 22, that only 18% of students get correct. So those are problems you want to be able to identify and not spend a lot of time on. Or there's other ones like 28, only 13% of students got it correct, which is sad because random guessing would be 20%. So basically people are dumber than monkeys who could just guess randomly. Just kidding, that was rude. You're not dumber, they're not dumber than monkeys. Okay, but anyways, so let's look at 87. And a lot of these you might be thinking, I got a lot of these wrong, that a lot of people got right. That's because we still have a lot of time to review. So again, I don't want you guys to beat yourself up if you're struggling still. That's still normal at this point. You just don't want to be struggling in May. All right, so 87. So an object traveling in a straight line gives us an initial position. So whenever I see initial position, I think integral. I'm going to use the space a little higher, I think, about right here. So for this one, I'm going to say final position. So I'm doing this for 87. So final position equals starting position plus net change. So the very first problem we did today was from 2014. It was, I think, number 81. I told you that problem shows up every year. Here it is again. You have to be able to understand one big application for integrals is net change. So this is going to equal, where did the object start? Someone turn their mic on and tell me where it started.
Wait, what?
What's the starting position? The starting y coordinate.
At 2?
At 2.
Wait, is it 2 or no? Or 0?
Yeah. No, 2 is correct.
It's 2?
0 is the time. So we're starting at
Oh.
2 at 0 seconds, or 0 whatever units of time. Plus the net change, that's going to be an integral. So we're starting at 0 seconds, and we want to figure out the time after 3 seconds. So the net change would be from 0 to 3 seconds. So we're going to undo a velocity, because if you undo a velocity, you're undoing a rate of change to get to the position. So the accumulation, the total change in position here, would be the integral of the cube root of 1 plus t squared dt. And then here, this is one you would need a calculator for. You would plug this into your graphing calculator. And this is going to give you approximately 6.512. So don't forget to add 2. So the integral would give you about 4.512. And then you add 2 to that, because that's the starting position. You have to add where you started. So you're starting at a y coordinate of 2, and you're going up 4.512 to finish at 6.512. You're not going up, you're going to the right because you're moving along the x-axis. Okay, other questions? Oh wait, did someone ask one?
86,
sorry, you're gonna have to
please.
remind me.
Can you do 86?
80,
Yeah.
You said 86? Yeah, let's do 86. Who's calculus god? Is that Meyer? Sometimes I just like to see who's here so I can appreciate everyone. Okay, so 86, right? One more time, sorry. You said 86?
Yeah.
Okay. So I was double check. All right, so 86. Okay, so for this one, it's asking about the slope. So that means I have to take the derivative. So I'm gonna find, let me actually scroll, it's okay. So the slope, so I'm gonna take the derivative. So on 86, the derivative f prime of x. Okay, the slope of any point is twice the value of x. So that means, this one's interesting, it says the slope is. So f prime of x represents the slope. The word is means equal. Twice the value of x would just be 2x. So that's how you would write the slope. The slope, f prime of x is, so it equals twice the value of x, so equals 2x. Okay, then it's asking me about f of 3. So I have to get back to the original function. So I'm gonna take the integral of this. So if you integrate 2x, you're gonna get 2x squared over 2, which is just x squared. Don't forget the plus c. So you're given an initial condition that helps. Anytime they give you an initial condition, that means you have to solve for c. So I'm at f of x is 3 when x is 2. So when you solve for c here, 3 minus 4 is -1. So I'm going to take -1 here. So I'm going to rewrite this function, f of x. It's going to be x squared minus 1. So now I have a function for f of x that's going to allow me to find f of 3. So just plug 3 into this. So this is going to be 3 squared minus 1. So 9 minus 1 is going to give you 8. So the answer is C. So always think about what you're given and what you're, more importantly, what you're being asked. So you're giving something, you're given information about the derivative, but you're asked for information about the original function. And same thing when you're working with graphs. Think about what they're giving you and what you're being asked to find. So other questions on this page?
Can you do 81?
81, yep. Okay, so on 81, I'm gonna clear this out. Okay, so on 81, we're asked to find the integral from A to C. Okay. So using this and this, it's both based on f of x. Using a property of integrals, I can say the integral from A to C. So it's kind of like, just, you don't have to write this down, but if you had an area here, you had A, B, and C. If you add the area from A to B plus the area from B to C, doesn't that give you the area from A to C? So that's what I'm using here. So I can rewrite this as the integral from A to C of f of x dx. That's going to equal, you know what? B needs to be at the bottom here. So I'm going to rewrite this integral as the integral from B to C, f of x dx. That has to equal negative q. So when you switch the limits of integration, that's going to be negative. So I'm going to write this as the integral from A to B, f of x dx, plus the integral from B to C, pick up where you left off, of f of x dx. So this is going to equal, so the integral from A to B, it tells me is just p, and then we figured out the integral from B to C is negative q. So when I add it to negative q, it's just p minus q. Let's see here. So now I'm going to focus on g of x. So using this information here, and then I would write same thing. I'm going to switch the b and the c. So I'd go from b to c of g of x dx. When you switch the b and the c, that's going to give you negative s. So I could say the integral from a to c of g of x dx. So same idea as what we just did. It's going to equal the integral from a to b of g of x dx plus the integral from b to c of g of x dx. And this is going to equal, we have r, and then the next one we found was negative s. So it's going to equal r minus s. So we're almost done. So the last thing we want to find is the integral from a to c of f of x minus g of x. So that's going to equal this, which is your f of x, minus this, which is your g of x. So let me actually erase this so I have more room. So this is going to equal p minus q minus, and I need in parentheses, r minus s. When you distribute the negative, you get p minus q minus r plus s, which looks like it's, I think, letter B. Yeah. That one's teasing my brain. So this might or might not be a treasure for you. Not everyone's treasure is the same. If you see this and you're like, oh, I'm good at properties of integrals, so you want to spend some time. For others of you, this might be one to skip. Okay, other questions on this page?
83.
You said 83?
Yeah.
Okay, yeah, let's look at 83 now. Okay, so on 83, I'm going to use the space above 83 just because I have more room up there. So on 83, if you want to find the area enclosed by the two curves, you're going to do the area of top minus bottom. So using your calculator, you can see which ones you would set these two things equal. When you set these two things equal, you're okay using your calculator to solve for x. So you'd find the intersection. When you graph both of these and find the intersection of the 2 points, one of the intersections would be 1, the other intersection would be 2. And if you go from 1 to 2, this one is on top, this one is on the bottom, from x equals 1 to x equals 2. So whenever you're finding the area between two curves and you're moving along the x-axis, you always do top minus bottom. So this is the top graph. Minus the bottom graph, which is x plus 5. And then from here, you can plug this into your calculator. And this is going to give you about 11.833. So is that okay for 83?
How do you know what the bounds are for?
So you'd have to graph both equations. So you'd have to graph this one and this one. And it would look something like this. So it might look, one might go like this, one might go like this. So the x-coordinate of this point would be 1. The x-coordinate of this point would be 2 on your graphing calculator. You'd have to find both intersections on your calculator.
Okay, thank you.
Is that okay?
Yes.
Okay.
Can you go over 89?
89, yes. So I'm going to clear this out. So 89. These are usually where the hard problems, the hardest ones are, the end of the graphing section. Okay, so 89. And not always. Once in a while, there's, like I said, there's treasures in unexpected places. So you have to be able to identify them. So 89. The function is continuous on the interval from -2 to 2. So maybe I'll draw a graph. That's always a good place to start if you're stuck. So -2 to 2, it's continuous. It says f of -2 equals f of 2, which equals 0. If there is no c where, if there is no c, no x value in between them, for which the derivative is 0, which of the following statements must be true? Okay, for A, for k to be between -2 and 2, f prime of k has to be positive. Well, that's not true because part of the graph's going to have to go up, part of it could go down. So the derivative is not always going to be increasing to get from this point to this point. So it's not A. For B, it says the derivative is always less than 0. Same idea. It's not always going to be decreasing. So the goal is to get from this point to this point. It's kind of a fun problem. And B is saying it's always decreasing. Well, that doesn't have to be true because it could go up and down. For C, f prime exists. That doesn't have to be true because you could have a cusp for some k. It says which, oh no, here it says f prime of c equals 0. So I'm basing it off of this. So f prime of k, let's see, f prime of k exists. It doesn't have to exist because it could. Here it's saying if there is no c for which f prime of c equals 0, then it wouldn't exist. So it's not going to be c. For D, what it's describing here, it says there's no c for which f prime of c equals 0. So that means there probably has to be a corner somewhere. So it's probably going to look like this. It might go up, then it might be a sudden change in slope. That's because if f prime of c equals 0, at some point it would have to turn gradually, right? Like if it looked like this, right here, f prime of c would be 0. But according to the directions, this doesn't happen. So it never has a slow gradual turn. So it has to be a corner or a cusp. So D would be true. So there has to be some point where the derivative exists. Or wait, I'm sorry, no, but not continuous. It's not D. This was a tricky one here. Because it is continuous at a corner. This is saying it's not continuous.
Mr. Morrison,
Yeah.
if there's a cusp, is it still continuous?
Yeah, a cusp would still be continuous. So if you like graphed like y equals x to the 2/3. Let me check that here. Just want to make sure I'm giving you the right graph. Yeah. So if it'll look like this, it'll come down like this, but it'll be a sudden change in slope. So I never picked up my pen. So it's still continuous at 0.
But because there's a sudden change in slope, it's not differentiable?
Correct. So at this point, it's not differentiable. So that's why E would be true, because there has to be some point where the derivative does not exist. So that would be at this point right here.
Okay.
Wait, Mr. Morrison?
Mm-hmm.
Would removable discontinuity still be considered as differentiable?
Removable discontinuity. Removable, that means you can fix it with a point.
But it wouldn't, right? Because it's not continuous?
Yeah, removable discontinuity wouldn't apply here because if it's at the hole, it says up here that it's continuous. So even if it's any type of discontinuity, it wouldn't be allowed here. So some of these questions really get you thinking. That one was sort of a tricky one for a which one must be true problem. Okay, other questions on this page? Okay, I guess I'm gonna wrap it up then. Thank you guys, I really appreciate